Good evening, everyone. Can you please confirm if you can hear me? Tanuj Gupta, the session is not yet started. We are going to start. And Archana, what about now? Can you hear? And Pavan, Namita, welcome to the session. Satvik, welcome. Vamshi, Shruti, Anirudh, Mohammed, welcome to the session. Awesome. Good to hear that, Tanuj. So, can you see the screen as well? You should be seeing our website. Chitra, let me let me ask everyone. Can you hear me? So in a few seconds, you should see a poll on your screen. Just answer the poll. I can clearly see that 95% of you can hear me and 4% cannot hear. So what I would recommend is please refresh or try connecting it from your laptop or desktop. Mobile phones, I would not recommend it unless and until you have no other option. But we would recommend you connecting on your laptop. Awesome. Good to hear that, Sarah. Yes, session recording will be available, Shashwat. Hey, Sarah, we are from Hyderabad as well. So welcome. Awesome. Now let me ask another question. Can you all see the screen? So I'm also going to put a poll question for that. You should be seeing our website. So I'm also going to put that. And can you guys please confirm if you can see my screen? Awesome. Riti is saying the video is hazy. That could be the internet issue. So Venkat, we are conducting this session live on YouTube. So after the session, it should be directly in our playlist, in our YouTube playlist. So you can pick it up from there. So Sanjay, I would recommend you refresh your screen and probably use an earphones or something. Awesome. So I think Sharath has joined the session. So Sharath, can you hear me? Can you confirm if you are?
Enoch, actually, I'm Bharani here, and
Okay.
Sharath has given me this link to join, and I've joined. Is there any different link for me?
Yes, Barney. I'm just going to forward it to you.
Yeah, you forward it to me. I will leave the session and join using that link.
Sure. Prem, right now there is no link as such. And what I would recommend you guys, for those of you who feel that the screen size is too small, I would recommend you to close the chat option and within your Chrome browser or whichever browser that you are opening, just zoom in. That will increase your screen size. No, Prem, we do not have anything on the LMS. So Riti, that's what I would recommend. First thing is check your internet connection, because it it really relies on your internet very heavily. And also, if at all you feel that the screen size is small, I would recommend zooming in from your Chrome browser or whichever browser that you are using. So within the browser settings you will have an option to zoom in. So I would highly recommend you to just zoom in and use it. Right. Yes, Ismail. In just maybe a minute or so, there was a slight confusion with the links, so that's why it's getting delayed. But so, Sandeep, what I'm saying is, probably let me share my screen and show you. That may be easier. So, for some of you may feel that the screen size is too small. So, what I would recommend is, now I believe you guys should be able to see my screen. What I would recommend is, go to your Chrome browser and use the zoom option here, and that will zoom your screen size, and that this is one of the workaround that we could use.
Hey, hello, Enoch. Should
Yeah.
I take over?
Yes, over to you, Varney.
Thank you so much for covering now. And hello, everyone, and welcome to the session. We have roughly 150 people who have registered, and a few more people will be joining in. While the other people join in, let me tell you that this is also YouTube live, right, Enoch? Enoch, are you there?
Thank you, Varney.
Is it? How many people are there on YouTube live?
Let me quickly give you the count.
Okay. While Enoch gives that count, I have a quick poll question on how many of you know me, and my name is Bharani Kumar. I just want to check on that. If you know, or let me rephrase this. Do you know me? Yes or a no? Yep. Please, can you respond to this question? Let's see how many of y'all know me. Okay. All right. Thank you so much. So there is none. Oh, okay. There are 6, 7, 10, 15% of people who do not know me. All right. I'm just checking out because I want to quickly introduce myself if you do not know me. All right. Point taken, friends. So everyone should know who is your tutor, who is your trainer. All right. So I would actually go to my profile. I'm pretty active on my profile, and I need to say that you would find approximately um, 800 plus CEOs of various companies, or someone at a CXO level connected to me. Okay, I am Bharani Kumar. I happen to be Industrial Revolution 4.0 implementer and a chief data scientist and technology advisor for 4 different firms. And I'm an alumnus of Indian School of Business and IIT with overall 15 plus years of experience. I happen to be director of InnoDataTix. I'm an advisory committee member of Sixbis, which is a Malaysian firm. I am a chief data scientist on Brontobite Analytics, which is a startup in the space of life sciences healthcare. Athena Global Technologies is a US based firm. I happen to be a chief data scientist, director of 360. I also work with Deloitte, Infosys, ITC, and HSBC. I happen to be an alumnus of Indian School of Business and IIT. And these are the bunch of certifications which I have, ranging from DSDM Attern to Lean Six Sigma Green Black and Master Black Belt to PMI certifications, etc. That was a pretty fast introduction because a lot of you all already know me. And here's my profile. If at all you want to connect with me, please go ahead. Feel free to connect with me. And one more quick thing, speed test, just to instill some confidence in you all that I am using a very high end internet speed for that case. And then this is called as Murphy's Law. Yeah, perfect Murphy's Law. So let me click on go. Let me test. I'm not sure if whether there is any other software available to test, but it's roughly 100 Mbps. Let me see if there is any other test. Speed test online. Yeah, let me run here. This is from Google, I believe. So it's approximately 100 Mbps. That's the internet speed that I have. So if at all you face any issues with respect to the connectivity, you know that it's not from my side, at least. Okay.
Barney,
Yeah.
while we are talking about this, we have about 100 people attending on YouTube Live.
Wonderful. Wonderful. All right. So now I am part of 360 Digit MG. This is a company that I have formed. Okay. And yeah, you might be seeing my videos in the other companies that I work with. Yeah, but this is the company that we have, and then we have our own niche of programs available. I will briefly speak quickly about that because you have raised that point. Let me quickly go to posts and activities, and let me show you a few posts that I've done. UTM, we have accreditation with University Technology Malaysia, which is ranked in 187th position globally. It means a lot, right? It means a lot. If you want to go for your higher studies, or if you want to go abroad and work, certainly they look at the global rankings. And this UTM ranking that we have is 187. That means a lot. And you can claim that you have done your PG diploma in the program. And then we have a lot of short tidbits available, which will in 20 minutes explain you on what is data science all about. We have built a lot of applications in the space of facial recognition system, which will track attendance, and also it is going to track your temperature. We have partnered with Panasonic India Innovation Center, and we are bringing in these kind of use cases also into our training curriculum. That's me, and that's the business head, and Krishna. He's a YouTuber, and he works with India Innovation Center, and 360 Digit MG has partnered. And we also have accreditation from City and Guilds. We have accreditation from IBM. IBM is, you know, you all receive IBM certificate if you get trained through us, kind of. And we have built in the past these kind of computer vision applications wherein this was done for government of Telangana for that case, wherein the moment a vehicle goes through this tracking box, it will automatically track and count the number of vehicles which are passed through that, and it will also create a count automatically in the backend. We have built an AI driven chatbot for Paradise. And why is this important? Because I'm going to speak now about text mining and natural language processing, and building a chatbot is very much part of that. You just scan it, chatbot opens like this, you place an order, and the food is delivered on your table, right? And this is behavioral analytics. One of a participant from Malaysia, she has worked alongside our team of data scientists. So it will put a bounding box. It will recognize your gender and your behavior on whether you're sleepy or neutral or things on those lines. Then we built a robot which is AI driven robot. This robot will actually recognize you and greet you. The name of this robot is Winnie. If any one of you happens to be in Hyderabad, do visit our office. You can actually shake hand with this robot. It will recognize you using video, and it will greet you. If you're happy, it will say, hey, it seems like you're very happy interacting with me. So such kind of witty responses also our chatbot delivers. So that's super cool stuff. Yeah. Anyways, shared my LinkedIn link. I'm going to share it with you. Please go ahead. Um, that's one thing. And let me poll another quick question before we get started. Let me reset. Since this is the first day, it will be a little, it will take some time for me to let me know on whether you're able to hear me or not. 60% are able to hear me. So that means another 50% of y'all have internet issues. Okay. So this is all I would say. If you are facing any issues, if you have any audio issues, then refresh your screen or connect using YouTube Live. And I'm going to share with you all details on how to connect using YouTube Live quickly. I don't want any of you all to miss out on this opportunity. So you go to 360digitmg.com and scroll down completely, and you please click on this link, which is given here. This link, please click on this by visiting 360digitmg.com. Once you click on this, you would go to our YouTube channel, and this is happening live. Please subscribe. Do not forget to subscribe, because you'll be able to view all the future videos and sessions if you just click on subscribe. Okay. We are extremely active on YouTube. So YouTube Live is happening. You just click on that and watch it. I think this should do. Okay. If you have any audio issues, then please do so. All right. Now I'll proceed further. Hello and welcome to this session. This session will be for 6 hours, 2 hours each day. So you are going to have today a session which will happen from, of course, it started at 8 p.m. It will go on until 10 p.m. Tomorrow also you're going to have the session at the same time, and Wednesday also you'll have the session at the same time. From tomorrow you'll not have any teething issues. It's only for today. Yeah. Having said that, let us get started. As part of this entire training, you will learn about introduction to NLP, data pre-processing from NLP context. How do you extract the features from the text? How do you perform topic modeling, text summarization, text generation, vector representation, and sentiment analysis? What are we waiting for? Let's get started. First 1 hour will be theory, and second 1 hour would be practicals. And we will be resorting to Python to explain you on how to implement NLP projects using Python. Okay, so let's get started. Text mining or text analytics is a method of extracting meaningful insights and answering questions from text data, only text data. Okay. And on the other side, if you look at NLP, NLP is not restricted to text data. Speech also falls under the purview of NLP, natural language processing. So when you deal with your textual data and speech, the purview would be under NLP. However, if you're dealing with only textual data, then it is the study of analyzing textual data is called as text analytics. And do you know what? In the world that we live in, only approximately 20% of the data is structured in format. When I say structured data, if you can place the data in a neat tabular format, in rows and columns, in a nice tabular format, then this is called as structured data. Okay, and when you look at unstructured data, approximately 80% of the data, or approximately 80% of the data that we analyze is in unstructured format. And what is that unstructured data? We have videos, we have images, you have audio files or speech and textual data. And analyzing only textual data is text analytics. Analyzing textual data and audio is called as NLP, which stands for natural language processing. Okay, then NLP has two categories. What are those two categories? NLU and NLG. NLU stands for natural language understanding. What does that mean? Hold on, I'll let you know. Next, NLG. NLG stands for natural language generation. What does this mean? Hold on, I'm going to explain. Okay. First, let us try to understand NLU. This is a process by which an inanimate object means something which is not alive, like your machines, like your systems, like your robots. Now understand why I've shown you the chat bot stuff and the robot here. I've shown this because we are discussing about NLU and NLG. So a process by which an inanimate object, that means something which is not alive, like machine systems or robots, with computing power, if if this is able to comprehend the spoken language, this is called as NLU. What does that mean? Can you give me an example? This is a little complicated to understand. Yep, sure, I would. If you are standing in front of a door, okay, and if you say open the door, if you instruct the robot open the door, and the moment your system hears your voice, it will recognize your voice and open the door. This is a classic example of natural language understanding. Humans, when they speak in a natural language, the natural way of speaking, your system or machine or robot should understand and act accordingly. This is NLU. Your robots, systems, or machines are able to understand your speech while you speak in a natural manner, and it will take an appropriate action. All right. Next, we have NLG. NLG is natural language generation. What does this mean? Let us understand. This is a process by which an inanimate object, I mean, inanimate means by now it should be clear that something which is not alive, like your machines, systems, or robots, with some computing power, they are not just able to understand your thoughts based on your speech, but they are also able to respond back to the humans. So here it's kind of one-way conversation. You ask robot to open the door, it would open that. But if I have a two-way conversation, right, with the robot and a human, if this conversation happens to be two-way, wherein you ask a question to the robot and robot is going to respond back by understanding what you have just spoken, this is called as natural language generation, because you're having your robot speak with you in a natural manner. So you're generating the natural language from this robot, right? And I strongly recommend you all to actually go here on my profile in the posts that I've done. There'll be this post, watch it. Because this robot here will respond. Now I cannot show you because I have this headphones on, so audio I cannot play, but then you guys can certainly play, right? I've already given you my LinkedIn profile and you're free to connect. All right. So let me quickly recap here. Number one, text analytics is only based on text data. Natural language processing is based on text as well as speech data. And NLP is categorized as NLU and NLG. NLU is natural language understanding and NLG is natural language generation. Here it's a one-way conversation wherein you talk with the robot, and here it's a two-way conversation. You talk with the robot would understand, and robot would automatically generate the text for you and talk with you. That's called as natural language generation. Next, even before you proceed further, we need to understand about the various data pre-processing techniques. Very important. You need to understand about the data pre-processing techniques. And first thing is tokenization. Tokenization is a process of splitting a sentence into its consequent words. For example, if I make a statement such as 360 digit MG, digital transformation, management and governance, 360-degree services we provide, that's why. Okay, anyways, 360 digit MG is, say, awesome training institute in India. Here, if I say I want to generate unigram tokens, so whenever a text is provided, this text is broken down into multiple words. So 360 digit MG would be one word, ease would be another word, another token, awesome would be a third token, training the fourth token, institute would be the fifth token, in will be the sixth token, and India would be the seventh token. So you have all these unigrams, single word tokens. If you were to come up with bigram means two words, then this will be one word. 360 digit mg is one word, bigram. These two words put together would be one entity, one token. If you combine these two, ease and awesome together would be the second token. Third token would be awesome training. The fourth would be training institute. The fifth bigram would be institute in, and finally in India. These are the bigrams that you form. Okay. And then we also have trigram. Trigram means three words. So 360 digit mg is awesome would be one word, one token rather. Then is awesome training will be another token, the three word token. And then when I say awesome training institute, this will be another token. Training institute in would be another token. Institute in India would be another token. So these are all the trigram tokens that we have. So you have unigram, bigram, trigram. Would we have more than these? Sure, you can. But a few years back, people have done some research and they found that when they try to generate 4-gram word cloud, when they generated 4-gram word cloud, it has taken 2.8 days to complete this task with 140 GB RAM. Wow. Massive memory is what they had. Still, they had to struggle for 2.8 days to complete a 4-gram word cloud. So in real world, people do not do this. Okay. I can also show you a few projects that we have done for our clients. And let me show you one project which our own participant was involved. We have done this for Computer Science Corporation, wherein it was text classification. And we had taken all the data. This was data coming in the form of emails. People used to write requests saying that, hey, can you install my Office 365? My Mozilla Firefox isn't working. Can you fix it? I forgot my Lotus Notes password. This is a messaging application. I cannot access my emails. So in this way, requests would come in and you'll have to do this kind of word clouds. So we have done unigram word cloud. We have done a trigram. We did not dare to do a 4-gram word cloud there, because when you do a 4-gram word cloud, it was simply taking days together for us to complete. So we have done this analysis for a client, and then we have also built a classification model wherein we tried knife based classifier. We built support vector machine classifier, and SVM has given us better accuracy and with less time. So you have to balance out both accuracy and amount of time it takes. Okay, I'll speak about a few more projects also as we go along. However, tokenization has certain challenges. What challenges? If I have a sentence like this, that we have an office in United Arab Emirates, and if I want to take this document, it's called as a document, right? One sentence is called as a document. And then if I were to generate unigram words, one, uni means one, bi means two, tri means three. It says we is one word, have and office is one word, in is one word, united is one word, Arab is one word, and Emirates is one word. But the fact of the matter is that United Arab Emirates is a single token. But since you want a unigram, your system does not understand such things, and it would actually, you know, segregate these three words as unigrams. So United Arab Emirates, which is incorrect, right? Because you have Arab nations. This Arab could mean that. Emirates could mean airlines altogether because we have Emirates Airlines. United could mean what? United Nations or United States of America? What would that mean? So unigram doesn't make sense uh, in this context. So these kind of challenges arise. So maybe you will have to try out trigram, etc., to address these kind of issues. Number one. Number two, we have something called as parts of speech tagging. Very important, friends. Parts of speech tagging is very important. It comes in very handy during your analysis. Parts of speech tagging means your sentence that you have is broken into respective parts of speech, and then you give labels to them. Okay, you give labels to each of those. For example, if I say that, let me take my name basically as Bharani Kumar is CEO of 360 digit MG. Now here, Bharani Kumar is a proper noun, right? So within parts of speech tagging, of course, in the hands-on session, you learn more. This will be tagged as N, N, or N, N, uh, P. N, N means it is a noun. This is how it is tagged in parts of speech. This is how it's going to tag. Or NNP. NNP means it's a noun singular. Unfortunately, the naming convention is like this. This is singular. P means. If I say tigers are fighting in jungle, tigers here would be given a tag NNS. S here means it is a plural noun. Unfortunately, they should have given the other way around, right? They should have told P is for plural, S is for singular. I don't know. Maybe they wanted to make our life a touch difficult. Who knows, right? But then this is how the naming convention is when it comes to parts of speech tagging. If I say fighting, what do you think is fighting, friends? Let me ask a question as a poll here. There is an option to poll you guys, and you guys can respond to the poll. And the question here is, let me add a new poll. What is which part of speech does fighting belong to? Is it a noun or mm, is it a noun or is it a verb? So let me again go here. Yep. Please, can you respond to this poll, friends? The poll question. I request you all to respond. And this was my question. Tigers are fighting in jungle. What is fighting? Is it a noun or is it a verb? And I would give you quick 10 more seconds to respond. And I'm going to look at your responses. Let me see. Wonderful. 96% of you all are saying it is verb, and that is right answer. So it is a verb. So do you know what? It will be given basically V, B, and G. Because it is a verb, G means they are fighting now. It's a present participle. Present participle. And then it becomes an English training otherwise if I just do not quit it at this point of time. Okay, let's move on. POS tagging, parts of speech tagging, is also called as post, or it is also called as grammatical tagging. Grammar, you're tagging the grammar in some sense, right? So these are a few things that I've listed down here. NNS means noun, plural. NNP means proper noun, singular. NNP means proper noun, plural. JJ is for adjective, VB is for verb, so on and so forth. Your system will do it. Tokenization, POS tagging, your computer Python program would do it. And we will learn that in another 25 to 30 minutes from now. There'll be practical session using Python. We also have stop word removal. You take all the bunch of words, you apply stop words filter on that, and you get the words, all the words except stop words. Now, your obvious question to me should be, hey, all this is fine, but what are the stop words? If you have the words such as a, and, the, is, are, but, however, these kind of words, if they are used in your sentences, they do not bring in value apart from giving a good grammatical sentence. It will just help you formulate grammatical sentences, but otherwise, it does not make any sense. These are the kind of words which are called as stop words. Every language, I'm not speaking about English alone, German, French, Malay, different languages have different stop words. Hey, where can I get it? It's simple. You just go do a Google search and then you'll find it. And this is a stop word document that I have, which I have downloaded from internet. Go to internet, you search for it, you'll find it. A few of these stop words are updated by Oxford in terms of dictionary. A few of those would be updated by thesaurus, and different dictionaries you have, right? Different people do it. Okay. Next, text normalization. You have terms such as Gurgaon, Gurugram, both mean the same. These are the words which are spelled, pronounced, or represented differently, but they mean the same. Bengaluru, Bangalore. Mumbai, Bombay. Chennai, Madras. UK, United Kingdom. And in Malaysia, they speak Malay language, or people also call it as Bahasa. These are all the different words which have the same meaning. So text normalization is a step used to convert different such variations of the text into a standard form. That is text normalization. And within this text normalization, you have three things. One is called as spelling correction. Another is stemming. And the third thing is lemmatization. Spelling correction, stemming, and lemmatization. So let us discuss about these three. Okay, and then we would proceed further. And even before that, friends, quickly, let me briefly give you the history on how things have emerged, right? It really makes sense for us to understand. So let me take a slight detour. Sorry about that. Do you know what? This NLP came into picture not now, way back in 1930s. How do you know? Because that was a time when the first patent was filed. First patent was filed in 1930. Oh, wow. Approximately 90 years back. And then things kept on emerging. And when in 1990, your World Wide Web, triple W dot websites, right? World Wide Web came into picture, NLP came to limelight. Okay. And then in the year 2000, IBM Watson, okay, was coming into picture. Then in the year 2010, people came up with a lot of concepts such as word embedding. And in word embeddings, we have word to vec, we have glove, so on and so forth. We'll discuss about these. Usually we discuss about these as part of our artificial intelligence training, but this is how it is. And this is when deep learning started finding its foot into the natural language processing as part of your recurrent neural network. You have long short-term memory, you have gated recurrent units, you have BERT, then you have XLNet, you have transformers, okay, and then um, ULM fit. There are many such frameworks which are becoming extremely famous. This is how the history started off. Okay, when it comes to your natural language processing. And one more quick thing that I want to show you guys without wasting a lot of time here is that if you go here and then go to AI and deep learning course that we have is going to include all these algorithms, which would mean a lot in terms of LSTM, GRUs, autoencoders, variational autoencoders, RBMs, DBNs, GANs, reinforcement learning, Q learning, speech recognition, and here is where we will spend time on the advanced, NLP algorithms, BERT, Transformer XL, XLNet, so on and so forth. And we have also included auto AI, which is coming into picture in a big way. You all know ML is a component of AI, so it's auto ML concepts, hyperas. How do you build it on AWS, Azure, GCP, right? And auto ML box, auto nets. And what do we mean by explainable AI, which is fast coming up into practice, right? Explanation by simplifications, Lime, SHAP, QII, SA. All these are futuristic, guys. And back to our discussion. Yep. Next, spelling correction. When you start typing something on your Microsoft Word, if it's an incorrect spelling, then you'll find a twiggle underneath your text. You right click on that and fix it, right? Or if you're typing something on mobile, your mobile will automatically correct the term. It most often than not behaves like your wife, right? I mean, spouse. I shouldn't say wife, spouse. They will automatically try to correct, even if there is no need. You experience that, I'm sure, right? That when you type something, you don't want it to change, but it changes. Auto correction sometimes is painful, but then, yep, it's making our life easier. So this is one of the most important tasks in any NLP project, and we can use a library within Python which is called as autocorrect, which will automatically correct your spellings. Data pre-processing, big thing. Remember, 60 to 80% of your time you spend only cleaning your data. Okay. We'll speak more about stemming, but look at this. These are only a few rules that we have written here pertaining to stemming. If you have something called as played, okay, then what happens is according to stemming rules, you remove ed and it becomes play, which happens to be your base form of the word, base form. Okay. And if you have a word such as playing, wherein you have ing, you remove that ing and the base form becomes play once again. If you have a word which is going to end with ly like this, lovely, then remove ly and then it becomes love. When you have, on similar lines, when you have battling, what would your stemming process do? It will remove ing. That because that's one of the rules. If you remove ing, the output will become battle. I mean, e should be there, it's not there, and this is incorrect English vocabulary. Since these kind of challenges arise, we proceed further with lemmatization. Lemmatization is a technique which is better than your stemming. And what does this do? This is going to do an additional check by going through your dictionary to extract the base form of the word. And in the dictionary, if battling has no base form, and if the dictionary says that, do you know what? If it is battling, it has to be exactly the same as an output. You cannot do any stemming, any changes to that. Then the end result would be battling. When you apply lemmatization, it would not create irrelevant, words. Then another important thing is NER, named entity recognition. Named entities are usually not present in the dictionaries, so we need to treat them separately. It will extract names of people, names of places, names of organizations, quantities, percentages, so on and so forth. If I give you this example that Sharath purchased 300 shares in Oracle Corp in 2005, then the name Sharath is people, belongs to people. How much did he purchase? 300, which is a quantity. It will extract this. Your NER technique is going to extract, and we will see all these things practically. Okay. And you have Oracle Corp. Oracle Corp is an organization. It will automatically extract such details, and you can use those for further processing. Then there is something called as word sense disambiguation, meaning a word's meaning depends on its association with the other words in the sentence. For example, if you say, he can play multiple music instruments. Now, play here is giving some meaning in this context. In the second context, wherein you say, dear DJ, please can you play the rock music? Here, this play means something else. Third, let us all play cricket. Here, the meaning of play is something else. So, two or more words with the same spelling may have different meanings in different contexts. And those contexts can be identified using disambiguation, which is a process of mapping a word to the correct sense it carries. Wonderful, isn't it? Yeah. And then you also have sentence boundary detection here. This is a method of detecting where one sentence ends and where another sentence begins. Do you know what? When I say this, people are like, ha ha ha, such an easy thing. And this guy is making big noise about this. Then here is my question. Is full stop an indicator of sentence stop? Yes or a no? Okay, so let me type it here as a poll question. And let me see how many of y'all will get it right. So the poll question is full stop an indicator of sentence stop? Please respond as yes or a no. Let me see how many of y'all will get right. Yep, Over to you guys. Is full stop an indicator of sentence stop? Yes or a no? Let me see. How many of y'all will get it right? 67% of y'all say yes. Another 32% of y'all say no. So let me see. Or let me give you the answer for that case. What if I say PM or AM? If I say PM or AM, then what happens here is you'll see a dot, full stop. That means should the sentence stop there? If you say 9 AM, anti-meridian, by looking at this full stop, your algorithm shouldn't stop. If you say 9 PM, then your algorithm shouldn't stop. It is called as post meridian. Okay, and also sometimes it might be etc. Full stop like that. The moment it observes a full stop here does not mean it's stop of a sentence. So all these techniques you're going to learn now practically. Okay, one more quick thing. Tokenization can be done using something called as regular expressions. So let me show you that there is something called as regex 101. Go to regex 101 and you just copy paste some text basically. So let me do this. 360 digit MG, you know, Bengaluru or some location. If I were to type it, it will give some address. Okay, I'll just copy that address and just copy this address and where did that go? Here. Yeah, regex. Let me paste it here. Come on. I was using some other, sorry, key. Copy, that's okay. Let me put it here. Okay. If I want to highlight capital letters from A to Z, if I just type A to Z in the square brackets, it is going to highlight all these capital alphabets. Okay. If I type A to B in this way, it is going to capture all the small alphabets. If you want to select only the numbers, you just change it. This regex will quickly help you perform certain actions. And this piece of information would usually go into your programming in NLP programming or text mining. We also have something called as text blob. This text blob is an NLP library within Python. You can perform a lot of operations if you have this. For instance, number one, you can do parts of speech tagging. You can do noun phrase extraction. You can also perform sentiment analysis. Okay, and then you can actually perform classification, translation. You can do polarity score. Okay, wherein you get words in the range of -1 to +1. -1 means negative statement, +1 means positive statement. And we've also done a specific project in that space for one of the clients. Let me show you that. It's here for Cat Center. We have done it. And here we have that polarity score. Okay, you have this -1 and +1, 0. Anything above 0 is a positive word. Anything below is a negative sentiment. Okay, that's how you can actually come up with polarity plot. Okay, and then you have a lot of tokenizers. Very important. After this, I'm going to stop and then we will do a practical hands-on until tokenizers will do it. Extracting tweets from Twitter is so very important that we have an exclusive, tokenizer, which is called as a tweet tokenizer. It is specifically designed for tokenizing the tweets. It is capable of dealing with emotions and expressions of sentiment as well. And then we have something called as MWE tokenizer, which is called as multi-word expression. If I were to just say that, we have state of the art learning management system. Okay, if I were to make the statement, if you do not do MWE tokenizer, then state would be treated as one different word, of as another token, the will be another token, this. All these will be treated as different tokens. But MWE, multi-word expression tokenizer, what this does is it is going to put simple hyphens over there and it will start treating this as a single token. So the words, multiple words, which are supposed to be treated as one entity would be treated as one entity. And then we have regular expression tokenizer. It's developed using regular expressions. Sentences are split based on occurrence of a pattern. So you'll have a pattern and then you can, look at that pattern. Then you have white space tokenizer. White space tokenizer means it is going to split a string whenever a space or a tab or a new line character is present. Okay, so for example, if you have these two words which are separated using a comma, which is a space, this will be treated as one token and this will be treated as another token. Sometimes you might separate those with a tab. Okay, you can just simply do this. You can say, all right, let me open this and let me type Barani tab, Mar tab, is CEO of tab. So tab will not give a single space. It will give you multiple spaces in that way. So you can also segregate the terms and create tokens if they are tab separated. And you will also have new line character, means after a line you put like this, especially in your programming, etc. You do this, right? You just say /n. That means from here it has to move to the new line. The text has to go to the new line. Even if there is a new line character, at this new line character, it will split your string of words. For example, if it says sentences are split based, and if I put like this, that means from here it will start treating this as a separate entity or a token. And finally, you have something called as word punct tokenizer. Okay, here what happens is each character can be split in this way. If you have text block T, E, X, T, you can split in that way. And if you have digits, for example, if you have a pin number, then each of these words can be split as different characters. All right. Then, um, I need to take this route and do this also? Mm, okay, I'll do one thing. I will do the stemming part of it, and then we will actually do the practicals in Python. Okay, is that okay, or do you want me to proceed further with practicals first? And I will take a poll. Majority wins, of course. So this is a democratic nation, so we go with majority. So here is a question. Should I explain another concept and then practicals, or let us get into practicals and enough of theory? So what do you like? Let me ask this question. Yeah, please, can you respond? Hmm. Race is on. Yeah, and then I'm sure you guys want practicals now. So okay, I mean, tomorrow and day after we'll anyways cover the remaining part of the theory, friends. Okay, so do not worry on that front. I think maybe we'll have to respect majority, as I've told you. So Sharath, over to you. You might want to get into the practical world. Sharath, are you there? Mm, okay, just allow me a minute, quick minute. Let me call Sharath, and I think he is not able to hear me, maybe, or not sure really. Just give me a bit. Yep. So Sharath would be joining in a minute. And while Sharath joins, quickly let me tell you that we have an amazing mind map which is available. And here we have for entire data science. A lot of things are explained here about maybe data types, imbalanced data sets, how do you actually go about handling imbalanced data sets, etc. You just need to go to 360 digitmg/mind map, and you would find all these things as part of data cleansing. For example, you'll have a lot of data cleansing, you know, techniques which exist. And let me also take this link and post this link for you all on chat, and you'd have fun.
Bunny, can you hear me?
Yes, yes, I can hear you.
Okay. Yeah.
Right? Yep. Over to you, Sharath. I'm stopping this screen share. Yeah, it will be practical, Sanjay. I mean, guys, it'll be little difficult to take break at this point of time because it's all practicals. Because tomorrow and day after also we have quite a few things to be covered. Yep. Over to you, Sharath.
Yeah. Thank you, Bunny. All right, friends. Assuming you all are able to see my screen and hear me clearly, that's the point that I need to get clarity on. Let me just
Yeah,
quickly
crystal
post.
clear. You can, I think,
Okay.
proceed.
Wonderful. All right. Thank you, Bunny. All right, guys. So let's start dealing with the text mining in Python. Let me just set the context. We have two programming languages, right? R and Python. And coming to the text mining and NLP, Python is more mature than R because of the computational burden that it puts on the programming. And R, being single threaded software and memory based software, does not handle the text data, especially when you have a large content. So try to focus more on Python. That's a suggestion that I would want to make. And let's jump into the subject. So I'm trying to first define a string here. And I'm calling it as a sentence. We are learning text mining from 360 digit ng. This is a simple string right? It's a data type is string, it is a single string, and it is having this content. Now, does the string have a value, a specific word? We will be able to try and apply this single line. We are saying text mining is this is a word, whether this is present in our variable or not, in our data or not. In is the function which is used here to verify. So we are taking text mining, and internally the string is being read as words. So text mining, V, it is comparing. No, these are not same. Then R, it is not same. Learning, not same. Text mining, oh yes. So it is able to successfully find it, hence it results as true. Now I also want to know what is the index. This index function is giving us the first position, right, where this particular word starts. So here, if you see, it is starting at this position, right? So we will be looking at, okay, let me just take this scribbling pad. Give me a second. I just want to write on that screen. All right. So the index in Python starts in 0. We know that. So 0, 1. The space is also, right, occupying memory object, memory space. So it is also given a index. So where does it start? Index is 7. Till 6 you have other letters, right? So we basically look into this now. Index should return me 7. Then we have a function, inbuilt function called split. This is the easiest function that we can think or imagine of. And this split function is basically trying to do tokenization itself. Wherever there is a space, remember English language is a space delimiter. So wherever there is a space, we will be splitting that and taking that words as separate entities. So let me do that. And of course, after that, I'm doing index of text mining. Observe what happens. It gives me the position as 3. So it is basically taking each word separately. That means it says V is one word, R is one word, learning is another word, text mining is another word, like this. So if I convert this single string into these entities, list of words, then this is 0, 1, 2, and 3. So your text mining, that word is at a position of index 3. These are very simple textual data manipulation commands. String data, basically, text data or string data. Next, split in square brackets, you're representing the index. So this should give me the value which is in the third position, learning. 0, index starts from 0, remember that. Now, coming to the next command here, this index that you are seeing is going to help you reverse your words. So I have taken learning right here. This is the word which basically is, I mean, that's the position which is giving us this word called learning. So when I put this syntax, it is going to reverse the order. You can see the letters are just altering the positions. G is coming in the first position, L is going to the last position. Now we have done the splitting here, right? The split is basically breaking up the entire words. So you will see that now. And look at that. That sentence, which is a string of one entry, is now becoming list of 6 different words. Right? So that split is the first form of doing tokenization. Now we can also identify the positions. Words in the first position, we have V, the word V. Then you can also get the last word. So if you don't know the length of the strings, I mean the number of words that you have, then you can use this length of words, and this would return the total size, and then you're saying -1. That would be your last. Remember, n-1 words would be there, right? Index starts from 0. So if I do that, I get 360 digit ng. Now you can also do operations, arithmetic operations here. Simple arithmetic, I'm joining the two words. This would just put V and 360 digit ng together. You can see print of that, you get this. We have not put any spaces or all or any special characters when I'm trying to concatenate these words, right? So it is taking as is. Next, I can write a for loop here. The for loop is to divide each word, right, by 2 and take the remainder. Verify if that remainder is equal to 0 or not. If it is 0, that means the length of each word that we are looking at should be even number. So if you see V, the length of V is 2. If I divide that by 2, I would get a remainder 0. Then R. R is equal to 3, so I will not get a remainder as 0. Learning. So how many words do I have in learning? 1, 2, 3, 4, 5, 6, 7, 8. So if it is even, then it is going to result in remainder as 0. And if it is remainder, if it is an even length number, then print that. You say that selecting those words. We learning from. So these are the 3 words which are of even length. Next, in Python, index, right, that we have learned is of course starting from 0, but you can also do count the index from the reverse order. So if you look into this, here V has indexes 0, 1, 2, 3, 4, 5, right? Now when we do reverse counting, it would be -1, -2, -3, -4, -5, -6. So the reverse index starts from -1, not from 0. Okay, that is for the list, this one. If you're doing it for sentence, then it takes each letter. If I have to write that for the sentence here, then it says 0, 1, 2, 3, 4, right? So on and so forth. G would be -1, M would be -2, T would be -3. So you want to print the last 3 words. TMG, right? Now the sentence, the entire sentence that we have should be printed in reverse order. So it is a single string, right? So everything is getting reversed. I don't want to print like this, but I want to hold the position of the words as is, but within that word, I want to reverse the position of the letters. If I have to do that, then I'm going to write word and treat each word separately and then print the reverse order. So for loop is used here, and you can see we are learning text mining from 360 digit ng. The position of the words did not change here, but within that word, the letter's position is changed. Now let us try and learn about tokenization. And we will also talk about parts of speech tagging. NLTK is the library, which is known as Natural Language Toolkit. And this library is the most popular library for textual analysis in Python. We are importing that. Then within this package, NLTK library, there is a function called word tokenize. Now this is to tokenize the words, right? We've already used split function, but this is another way to tokenize the words. I am reading NLP fundamentals. I want to tokenize this particular sentence. And you can see it is creating list of 5. Right? Now, when I did the tokenization or using split function, when I did tokenization of this, that would also actually give you list as an output. So both will give you the same result. It's just that different ways to do it. You can see words is now list of 6, and here if I apply words, it will now change that to 5. It's just the input is changing, right? So it will change the words. You can print this. It says each word is separated, tokenized now. Now on these tokens, we will be doing parts of speech tagging. Now, as we discussed, parts of speech tagging is to basically assign the nouns or adjectives, right? We are trying to understand those things for each and every letter or word that we have. And you can see here, I is PRP, AM is VBP, VBG, NNP, and NNS. You might be wondering what are these tags. So I have just listed them here at the bottom of the code. So we have NNS, noun, which is plural. NNP is proper noun and singular. Then we will look into VBG. What does VBG means? Verb. V means verb. We also have VBP, that is also a verb. Then we have PRP. Where is that PRP? Here. Personal pronoun. So this way, your parts of speech tagging happens with the codes. 36 different codes are there. And word tokenizer will first tokenize the words, and then we have parts of speech underscore tag, POS underscore tag function to tag the parts of speech to each and every word. Next, that's about tagging. Now, in these text words, there might be a lot of stop words, which are unwanted words. We basically use these stop words as filler words, which are used to connect two different words to create a context. Right? It tries to give you the context. Right? So we will be loading this NLTK download stop words. And this is going to download the predefined stop words into your folder where you have installed your Anaconda and updates it. Stop words are predefined, and there are 179 stop words in Python. We'll see that. So let me import these stop words now. Right? And I'm loading those stop words into a variable called stop underscore words here. And the language that I'm choosing is English language. 179 predefined words will be there. I, me, my, myself, we, our, your, him, who. All these are frequently used words. Right? So you can say print, you will get all those words printed here as well. Remember 179, that's the count. We will also have custom stop words, we'll see in future code. Right? We have that also. Now I'm creating a sentence. I am learning NLP. It is one of the most popular library in Python, NLTK library. So I'm importing this sentence, right? It's a string. And then I'm applying first tokenizer so that I get words, right? And then on these selected words are the tokenized words, we will have to compare these words with your stop words, And if you find that any word is present in that predefined stop words, then filter them out. So I'm writing here the for loop again. Take each word which is selected from these words, sentence words, right? Word for word which is taken from these sentence words, you will select it if this condition is satisfied. Word is not in stop words. If it is not present, then oh yes, you can select it. But if it is present, then this condition is not satisfied, so you'll not select it. And you can see there are few words which are eliminated. Like I am is gone. Right? Then we have is is gone, off is gone, the is gone, most is gone, in is gone. So these are predefined keywords which are there in the dictionary, stop words dictionary. Now I can also do some manipulations to replace the existing content. Here I'm creating sentence 2. And I want to replace the short forms, abbreviations. Right? There are a lot of intelligent tools, AI-based tools, which do this. When you're typing some short words, they identify the abbreviations and they replace it. So I'm saying I visited Malaysia from India on February 14, 2020. That's the context that I want to bring here. Now, because of this 2020, which is like repeating, right? We have compelled to write the full form, not just 2019, right? We generally write 19, but now we want to write 2020 full form in its full form. So I'm doing that. So for MY, I'm replacing with Malaysia. For India, I'm replacing it with full form of India. And this one, hyphen 20, will be replaced with hyphen 2020. Now see, the sentence has been altered. I visited Malaysia from India on 14 February 2020. Right? So this is how we replace the content. Then we have Speller. Speller is a library which helps us to correct typos, especially when you are trying to do some kind of textual analytics, right? And say, for example, customer feedback or product reviews. In such cases, these reviews are really, I mean, it's not a formal language that people will write. Customers are generally sharing their opinion, right? So they will not be writing in a formal way. So there might be a lot of typos. They don't focus much. So in such cases, Speller would come really handy. Import Speller from Autocorrect library. From Autocorrect, import Speller. But Speller has capability to support various languages. We are going to use English language here. So we are talking about English, so it takes, or we have to define the language as English. Now, if you see here, I'm applying the spell onto this word which is mistyped. So when I say spell, it is correcting that word. It says natural. Next, I'm defining a sentence here. Natural language processing deals with art of extracting insights of natural languages. If you carefully observe, there are a lot of typos, right? So I'm first taking the sentence, applying the word tokenization, right? This is your tokenized sentence. And then we are applying the spell function here that we have defined. Now this is going to correct each word and create that sentence back. So you're saying sentence, correct sentence. But one thing you have to see here is the speller is going to look into the predefined functions. Yeah. So let me show you that sentence, corrected sentence. Procession. It has a dictionary meaning, right? So spell function is not identifying it as processing, but it identifies it as procession. So it is basically written this way. There are certain challenges, nothing is foolproof. You have to be careful with these kind of corrections that your algorithm is doing. Next, coming to stemming. Again, I'm importing stemming from NLTK library. I'm calling Potter stemmer. I'm importing that as stemmer and see what happens. Stemmer basically is going to split the words into, you can say, stem and leaf. Stem and leaf form. For example, it can also be used in numbers. So if I have a word, numbers like this, 101, 120, 150, let's say 159, and let's say 199. So the common thing here is 100. So this becomes your stem number, and this stem can be added with 1, 20, 50, 59, and 99. These becomes your leaf, right? So stemmer is doing exactly that here. Programming. So program is common, right? So it identifies ing as a leaf word, s as a leaf word. So if I do this, it says program. For programs also, it says program. Now for jumping, it says jump, right? And if you say for jumper, because jumper has a different meaning, it gets a different parts of speech tagging completely, right? So it would be treated as jumper itself. It doesn't change. But when it is doing stemming like this, it has to remove ing. For sure, ing is a leaf word. So when it is removing this, stemmer doesn't look into the dictionary meaning. It just removes that ing, that's it. It doesn't put e there. So it cannot create that new word. That's the drawback of stemming, which is taken care by lemmatization. Now, lemmatization would always look into the dictionary meaning along with the parts of speech tagging. And it would split the word into stem and leaf only if it really makes sense and it has the same meaning. For example, let's import the word net, and I'm importing word net lemmatizer function. I'm calling that as lemmatizer itself. And then I do lemmatization on programming. Okay, yeah. Look at that. Programming. It has a different meaning, so it is not splitting it. Programs. It doesn't split this as well. Right? Singular, plural, that is also something that you'll have to look at. Battling. It gives us same battling because it has a dictionary meaning. So lemmatization is a little intelligent than stemmer. Stemmer does not look into the dictionary meanings. It just splits. Now this is chunking, which is also known as shallow parsing, identifying the named entities. So we are importing MaxNet chunker, NE chunker, that is named entity chunker, and also import down words. Now I'm creating a sentence here. We are learning NLP in Python by 360-digit NG, which is based out of India. I'm applying this NLTK NE chunking. And first, what we are doing here is taking the sentence, tokenizing that sentence, then applying parts of speech tagging, and then identifying named entities. Named entities basically means places, names, objects, or things, right? Anything that can be identified using a name, named entity. So look at that. Named entity. Python NLP, India NLP. So India is a location, it's treating that as a different named entity. Python is a programming language name or animal name, so it is treating it as a different entity. There might be, right, similar kind of location. I mean, locations would be there. So it identifies all those named entities here into the same section, right? So that's chunking for you. Now, like we have word tokenizer, here we also have sentence tokenizer. So I'm importing that sentence tokenizer, and I'll be applying this and then doing sentence tokenizer. So wherever there is a full stop, right, it is going to take a stop there. We are learning NLP in Python. That's a separate sentence, right? Then it says delivered by 360 digit MG. That's a different sentence. Do you know where it is? Here I don't have full stop, but you have a question mark, right? So it is treating that as another sentence. And then it says it is based out of India. So this way we are splitting the sentences, tokenizing the sentences. So along with word annotation, word tokenization, we will also have to look at sentence annotation, sentence tokenization if required. Then this is for disambiguation. NLTK WSD import less. Disambiguation will be handled here. Like the example what you have seen few minutes back, the word bank will have multiple definitions, and the way you use it would define the context there, right? So we can basically first define the sentence one and then say identify bank in the sentence. After first tokenize it and then identify bank. Define the disambiguation here. So it is saying sign set is basically a keyword. It is identifying, it's like synonym, defining the definition for bank. It's a coded message. We'll look into we'll decode this and try and understand what does this categorization means. Now bank I'm using here for a different context. Sentence 2. It's so risky to drive over the banks of the river. I'm defining this sentence 2 and then applying the disambiguation function. And here you can see the word bank is treated and categorized into a different value altogether. The code is 07 here. Here it is code is 02. N probably means noun, V means verb. Now, if you want to understand that, we can try and apply WordNet here. I'm importing WordNet. And in the WordNet, I'm trying to look at all the possible science defined for bank. And I'm printing those things. Now, if you see here, we first got savings underscore bank dot n02. And this is the instance. It's a container. Bank has a meaning called it's a container, usually with a slot in the top for keeping money at home. That's a predefined meaning for the word bank in this particular context. The other context that we were using the bank was categorized as bank.v.07. And if you look into that, yeah, bank.v.07. Cover with ashes so to control the rate of burning. then it has a different meaning. So it's trying to disambiguate, right? It's trying to basically identify the proper meaning for those ambiguity word. And yeah, these are the POS tagging, short forms, abbreviations. You can go through these as well. Now let us move on and look at further manipulations on the text data. Here we will try to understand how do we tokenize one word at a time, we have seen, but how about two words together or three words together? For example, here if you see Indian Army, you have to treat that as a single word. Republic Day, you have to treat that as a single word. Generally, those two are combined together. They're used together, right? So in such cases, you should have two words tokenized together. We call it as bigram, right? And we can basically do n-gram tokenization. We call it as n-grams. Though we will have n-gram, practically, we will not go beyond three words being considered as one token. We do not go beyond that. We already know what is RE. RE is the library regular expression for Python. And let me load my sentence here. I'm calling sentence 5. Loaded that. And here we are applying an inbuilt function in the regular expression, which is substituting the values with space onto the sentence. So these special characters that you're seeing, right? These are basically saying identify the special characters like hash, apostrophes would be there, at the rates, right? So these kind of special words would be removed and empty spaces put there. And then after you treat the sentence, then do the tokenization using split function. Now this is one way to split. We will look into, of course, different ways. But here, if you observe, it has cleansed the special characters at India underscore official. So it is removed that at the rate underscore, and then it says India separate, official separate. Then Indian Army, that is also removed. It's changed. So this way it is removing these special characters and then printing it. Now on this is a single 1 gram by 1 gram tokenization. We will be doing n-gram tokenization, and there are different ways to do it. We are trying to see 3 different approaches. One is using the same regular expression function. We are writing a custom function. We are defining this custom function. And here I have to pass the sentence as well as the number of words that you might want to tokenize as input to that custom function. You're defining it. So let us define this. So it's basically taking the words, tokenizing, right? Cleaning it and then tokenizing it. And then it is taking length of the tokens and takes 2 words together. Tokens I colon n plus 1, I plus 1, n, right? So if I apply this custom function to this statement, I'm passing a random sentence and I say 2 words have to be taken as a token. You can see here the bigram, we call it as bigram because we have 2 words coming together. So I say the cute becomes 1 token. Then cute little becomes another token. Little boy will become another token, so on and so forth. Right? If you want to try and apply 3 words Here, you just replace that 2 with 3. And you'll get 3 words taken together now. This is called as trigram. So maximum we will do is unigram, then we will go with bigram, and maximum we go with trigram. All right, so that's about multiple words being considered into the tokens. Now let us try and see how easy it is to tokenize if you're using n-grams inbuilt function. You don't have to write such a big custom function, not required. So just import n-grams, which is available in NLTK, and then apply bigram here, and then trigram. Just taking the inputs, it's splitting the sentence using 2 grams or 2 words together or 3 words together. Right. Then we also have text blob. This is another library which is present in Python, which helps you to perform a lot of textual analytics. Now make sure that package is installed. Now, NLTK, of course, you have to make sure it is installed. If it is not installed, then you have to use the pip command. So you can just say pip install text blob. Execute that. If NLTK is not there, you can say pip install NLTK. So it is installed. It's already there in my system present. And we are proceeding further to import it. And the function has the same name, but with the uppercase letters here. You have to be careful when you're functions. Then I'm applying this text blob, right, and converting or recording this sentence into blob. Okay, I got blob. Now, not be able to actually read it. It's just that same entry, whatever you define, right? So this is like you're defining what it would be your input. And on this text blob, along with your n-grams function that we have imported from NLTK, we are using this for coming up with bigram. So though it is using the same n-grams function which is available in NLTK, it does a little additional things here. Like it says it's a word list. Of course, it's the list for even all the other things also, it is a list. It's a different way to represent it. So there are 3 different ways to perform tokenization here, extracting n-grams. We call them as n-gram. And those are custom defined, NLTK and text blob. In custom, we are using that split function, string split function. Now we can also use Keras for tokenization. So let's say I'm using the same sentence that I have. I'm importing Keras. Keras is a function which is, or a library, which is used for deep learning algorithms. When you're doing NLP using neural networks, deep neural networks like LSTM algorithms and all those things, then Keras would really come in handy. So here I'm importing Keras and then using Keras to import text to word sequence function, which is available in Keras. And Keras, mind you, is a high-level library, high-level programming library. Whereas in the backend, Keras is using TensorFlow. It's an open source library for dealing with your neural networks, training your neural networks. TensorFlow is developed by Google. And yeah, it runs in the backend. It's a low-level programming abstraction. Keras helps the users to write very easy codes. and then it communicates that with TensorFlow, and TensorFlow actually gets the things done. So here you have text to word sequence function, which simply splits your word. Tokenization style. Then we'll also use text block. We have already seen. If you say words, it's splitting like this. In the previous case, we have used multiple n-grams. Here we are just doing tokenization. And yeah, these are multiple tokenizers that we have. Tweet tokenizer, MWE tokenizer, which is nothing but multi-word expression. Then we have regular expression tokenizer, white space tokenizer, and word punctuation tokenizer. So let me run through this. From nltk.tokenize, import tweet tokenizer. We have to import all these tokenizers from NLTK library. Majority of these are majority of the textual analysis tools or libraries or functions are part of NLTK. So I'm importing tweet tokenizer and just define that tweet tokenizer and tokenize your sentence using that. And it is taking each word as is. Wherever there is a space, use that for tokenizing. And these special characters are also treated separately. Then we have MWE tokenizer, multi-word expression. Import that. And this multi-word tokenizer has this capability to identify these two words which are generally used together as a single token. So you can have tokenization done where space is treated as delimiter for English language, but when you specifically define that, hey, I want to use these two together, then tokenizer would understand that and treats those words as separate. I mean, a single word. So here I'm applying MW tokenizer and defining that republic and the day should be used together as a single token. And I'm also adding this word as well, India, army. So this is one way, this is addition. We are passing now India underscore army also to be treated as same word. Now, when I apply this MWE tokenizer onto that sentence and split these words, you will see that the Republic Day has actually been identified as a single token. But at the same time, the Indian Army that you are seeing has not been identified as the same word. That is because of that apostrophe symbol that you see, which is there along with the army word. It doesn't have any space, right? So army apostrophe is treated as one entity. But you have not defined that here, right? You have defined Indian and army, two different words. Whereas here, army apostrophe is a different word. Now, if I have to make sure that Indian army also is combined as a single token, then you are replacing this apostrophe here into nothing. Basically, you're just eliminating it. No space, nothing. So when you do this, now you can see Indian Army. It is identifying that Indian underscore army as single token. Then we have regular expression tokenizer. And it is cleaning your special characters, identifying those special characters, and then you can clean those sentences and the special characters as well. You can put control symbol there. There would be a small cap symbol if you want to do that. Let me rerun this. Sometimes my Python gets hacked. So this is an alternative trick that I do to make sure I release the memory. So if you see, it is identifying these special characters and removing that. So you don't have hash. Oh, hash is there. Oh, okay, we have not put the cap symbol. If I put the cap symbol, then it is removing those things, filtering. If you don't have cap, then it says identify that special symbols as well. Right? So this is basically to identify each special character separately. Now, these are predefined special characters, friends. You have to basically look into the documentation of these packages to understand what all various special characters or these characters are available. Okay, and each of that tag will have different meaning. You can basically decode that. Then we have white space tokenizer, like the tab separation, and this is very simple tokenizer, just like the other tokenizations that we have. And then word punctuation tokenizer. This is again another tokenizer that we have. So it is going to identify the special characters as separate token. So this is your word punctuation, word punch tokenizer, punctuation marks, tokenizing punctuation marks as well. All right, so this is about the tokenizers. Okay, next we have stemmers and then lematizations, then singularization, plural. Then language transition is also there. Then we have custom stop words. All right, so we will be stopping here for the day. And we will continue from here along with the theory tomorrow. So we will be connecting through the same channel for tomorrow's session until we cover this NLP text mining concepts. Right, let me check your questions. Okay. Shantanu, executing parallelly would eat up a lot of time. Oh yeah, Bernie has responded. Okay, fine. Extracting words separately with respect to white spaces. Yeah, it's basically tokenizing. Right? Tokenizing means identifying each word separately with space delimiter logic. Every language has its own format of writing, right? I mean, we call it as character set. So English has a very simple logic. Write the words with space. So using that logic, it is going to extract the words. Hope you're able to hear me. Okay. Okay. Python files as that everybody would execute.
Yeah, hello guys, are you able to hear me?
Yeah, Bernie, we are able to hear you.
Yeah, wonderful. So yeah, we will be giving you all access to the YouTube channel. And friends, you will not be given these videos on the learning management system. It will be there on the YouTube channel itself. These are additional videos. And we want all the future batches to watch that. And this is first thing. So please subscribe to the YouTube channel so that the subsequent videos, you actually get access to those. And the code and data sets will be there on your learning management system. Okay. All right. So yeah, this is how it is. Thank you all so much. We will again connect tomorrow and take this discussion further. Thank you all, friends. Good night.